Now, question number 11 says, how is the inverse of a function determined graphically and algebraically? So we're going to be talking about inverse and how we can get that by doing algebra and by graphing it to make sure that it is inverse, that it is its inverse. So let's go ahead and get started. We're going to talk about inverse. Okay, so we're going to be doing this graphically and algebraically. So let's work with one example first. Let's say we have f of x is equal to x plus 4, and we have to find the inverse of x plus 4. Well, to find the inverse, there are certain steps you need to have. The steps are replace f of x with y. So let's replace f of x with y. That's the first step. Replace f of x with y. So we replaced it. Now, the second step is interchange x and y. So the second step is to flip these. Flip them. So x equals y plus 4. That's our second step. Our third step is to solve for y. So our third step is to solve for y. So to solve for y, to get y by itself, we subtract the 4. So it will be x minus 4 equals y. And it says replace y with f negative 1x. So y, let's just bring it to the side. Step 4 is to replace y with negative f of x. X minus 4. And this is our inverse. This is the inverse of x plus 4. And if we were to graph this, so we could see graphically, we graph the original function first, which is 4. And it would look something like this. And the inverse, it's always x. Every time you're gonna check the inverse, just place x in your calculator, and it will give you the line that goes right across the middle. That's how you can check. That's the inverse line, to check if it's actually inversely related. So let's plug in our answer that we got, our inverse. Let's plug that in. That will go to negative 4, right? So we draw that one, and what do you see? You have the exact same thing on each side. So in order for it to be inverse, they have to have the same thing on each side. Kind of has to act like a mirror. Kind of has to act like a mirror. But it has to have the same things on each side. So let's look at another example. Now we're just going to do it algebraically. So we have f of x is equal to 3x plus 2. What's our first step? Our first step is to change f of x into y. So instead of f of x, we're going to write y. Y equals 3x plus 2. Our second step is to change y and x. Interchange y and x. So it's going to be x equals 3y plus 2. And now we solve for y. So you take away 2, so x minus 2 equals 3y. Divide by 3 to cancel, and you end up getting your answer would be x minus 2 over 3 is f negative 1 of x, because remember we have to change y into f of negative. So that is how we got this part, this answer. And to go over it one more time, we first have to write it as y equals, then we have to interchange the x and the y, then we have to, after we interchange the x and the y, we solve for y, and then once we solve for y, we change y into f negative 1 of x. That is how you find the inverse. Remember, in order to do it graphically, you graph your original function and you graph your new inverse function, and you put x inside the calculator, and if it mirrors on both sides, then you have yourself an inverse function. And this is how you find the inverse function graphically and algebraically. There's just 4 easy steps. You replace f of x with y, you interchange x and y, so you switch them, and you solve for y, and once you have solved for y, then you replace y with f negative 1 is x. And remember to always graph your original function and your new function, and always put x inside the calculator so that you can get the line that goes right through it, and it has to mirror on both sides. So that is how you find the inverse function graphically and algebraically.